In today's lesson, we're going to look at validity in conjunctions and disjunctions, or and or statements. But more importantly, we're going to lead into talking about something called a counterexample. Now, when looking at and or statements, while it's not going to be required for us to know this on the test, it's really helpful to be able to create logical arguments. So if you think about maybe in your English or history classes when you might need to write a paper, knowing how to logically express your ideas is really important. So let's look at a few examples of this, but then we're definitely going to focus on counterexamples, as that's going to be the piece that you're going to practice a little bit more and what's going to show up on your test at the end of the unit. Alrighty, so conjunction statements, anything with an and symbol in it. So your and symbol, again, is your up arrow that we talked about in lesson 1A. And so the T's and the F's that I have in this chart are representing which pieces are true and false. So in our first example, we have T, up arrow T, which means we have a true statement and a true statement. So for example, Mrs. Burnside is wearing glasses and a sweater in this video. And both of those pieces are true. Both of those pieces of information are true. So that whole statement is true. Now, if we had true and false. So I am wearing glasses and I'm wearing a hoodie. Well, I'm not wearing a hoodie, so that is actually a false statement. And actually, if I combine any false piece in an and statement, it's always going to push that statement to incorrect. So I am wearing contacts and a sweater. Well, I'm not wearing any contacts, I'm wearing glasses. So that is a false statement. And then two items, I am wearing contacts and I'm wearing a hoodie. Well, neither of those is true, so the whole thing has to be false. So for any conjunction or and statement to be true, that means both parts need to be true. So both parts are true. Alrighty, well, we're looking at disjunction statements next. So that's when we have an or statement. So true or true for our first piece would be I am wearing a sweater or I am wearing contacts. Excuse me, I want to do true and true first. So I am wearing a sweater or I am wearing glasses. Well, yes, that's true. Actually, I'm wearing both. So that is a true statement. I am wearing glasses or I'm wearing a hoodie. Well, I'm wearing glasses, so that statement is still partially correct. So that's true. So it's a little different with or statements. As long as you have one piece true, you can say the whole statement is true. So I'm wearing contacts or I'm wearing a sweater. Well, yeah, I'm wearing a sweater. I am wearing contacts or I'm wearing a hoodie, and neither one of those is true, so that whole thing is false. So when you're looking at a disjunction or statement, so or statements, that means at least one piece has to be true for the whole statement to be true. So at least one part is true, and that makes the whole thing true. And going back to the and statement, just to clarify a bit, both parts are true means the whole piece is true. So and you need both parts, or you just need one. So let's check out a couple examples. And so these are, let's see, I'm going to stick with purple. So these are just random ideas, but things that we know are either true or false pretty straightforwardly. So first example, the sky is green is our P statement, and all people are unique is our Q statement. Well, the sky is green, and that's definitely a false statement. I've seen the sky be blue when it's nice and sunny out, and I've seen it be gray when it's cloudy out, and maybe red if we had, really pretty sunset or sunrise, but I've never seen it be green. So let's say statement P is false. All people are unique. Well, I would count that as true. Everybody has something unique about them. Even if you're thinking about twins or triplets, each person's going to have something unique about them with, how they do day-to-day tasks, or maybe one of them has a freckle in one place that the other twin doesn't. So all people are unique, true. So if we're looking at an and statement, in other words, P and Q, we're thinking about our false statement and our true statement. Well, again, for and statements, how many parts need to be true? Both of them. So this whole statement is false, unfortunately. As soon as we go over to the or statement, though, P or Q, or we can think false or true, well, we've got at least one piece true, that all people are unique. And so this statement is going to be true when we put those ideas together. Okay, second example. A triangle has 3 sides. Well, that's the definition of a triangle. It's a polygon with 3 sides. So that's true. A square has 4 sides with our definition. So both of these are true statements. So in this case, if both pieces are true, then no matter what's going to be the truth value of either our conjunction and statement or our disjunction or statement? Well, both of them will end up being true. So we have true and true, which again, we could just look it up in the chart above. That whole statement's true. We have true or true. Again, at least one piece is true, so the whole statement is true. So again, while these questions aren't going to be on your test, I still wanted to go over them just because, you need to use logic in other pieces of your life. More directly, you might use this when, again, you're writing a paper or trying to get an idea across, and I want you to be able to form logical arguments and logical sentences to be able to get your ideas out to another person. However, we did start thinking about, well, how can we prove whether or not a statement is true or false? And so this kind of naturally leads into our topic of counterexample. And so this piece is definitely going to be on our test. This is important to remember and important to be able to figure out what a counterexample is if you have a statement that you know is false. And so to get a little bit more specific on this, when we're talking about counterexamples, you're also going to hear us use the word conjecture. And so 2 definitions: a conjecture is basically, an educated guess on previous examples or an idea that you're putting out there. It's kind of like an untested hypothesis in your science class. You start all experiments with a hypothesis, and your experiment is all about proving that hypothesis true or false. And that's kind of like what we're doing here. So in each one of these examples for our second piece, I'm going to give you a conjecture, a statement, and I want you to create, and we're going to create a counterexample. In other words, an example that proves the conjecture false. So here we go. First conjecture: x squared equals 25 if and only if x equals 5. Okay, well, let's think about this. What are the values that we can square and get 25 out as an answer? Well, we can definitely do 5 squared equals 25. However, is that the only number we can square to make 25? Unfortunately, or fortunately, depending on how you look at it, we could also square -5. And we looked at this when you were doing distance, or we will look at this when we're going to do distance formulas in our next unit. We're going to use this math. So it's very important to remember that anytime you square a negative number, you're always going to get out a positive answer. And again, if you don't believe me, you can plug it into a calculator. Just make sure you notice I wrote parentheses around my -5. That's the same way you're going to want to write it into a calculator. I don't care if you're using a TI calculator or a Desmos calculator or the calculator on your smartphone. Always put parentheses around your number when you're squaring it. So our counterexample is actually this second statement, that because -5 squared also makes 25, then the conjecture was false. Okay, number 6, all teachers go to work at school. Well, I can tell you that I am not recording this video from school. I am recording this from my home office that I've set up. Forgive me, it's a little messy. That's why I have this whiteboard behind me. It's kind of blocking some bookshelves that aren't quite as neat as they could be. So and all of your virtual teachers are an example. A lot of us, most of us, are working from home as we're teaching. So, counterexample, virtual teachers working from home. Alrighty, conjecture number 7. If it's an even number, then its last digit is 2. So think about a number that you know is even. Can you think of one that doesn't end in a 2? Well, I can think of several. We could use 10. We could use 24. We could use 188. No, there any of those even numbers, we know they're divisible by 2, but they don't end by 2. So a lot of counterexamples you could use for number 7. And then number 8, every polygon has 5 sides. Well, wait a second. Didn't we just talk about polygons in one of our examples before? What are some other polygons or shapes that have sides that don't have 5 sides? Well, we could have a triangle. We could have an octagon, something with 8 sides. We could have a dodecagon, something with 12 sides. Those are all considered polygons. Poly mean many-sided figure, but they definitely don't have 5 sides. So any one of those would be a good counterexample. So again, focus in on your counterexamples. Check out the practice that we have posted today. But as always, let me or Ms. Milligan know if you have any questions on this topic.